All right, so we're told to find what is the f prime of f of x equals x cubed minus 1. F prime of x is another way to say find the derivative of f of x equals x cubed minus 1. So the derivative is basically the function that describes the slope of the function. So for example, to find any derivative of a function without given a specific point, you want to use the difference quotient, which is the limit as h approaches 0 of f of x plus h minus f of x over h. So here we have f of x plus h. So to find f of x plus h, you do the limit of h approaches 0 of f of x plus h. So you would plug that into this function. So it would be x plus h cubed minus 1. So that covers this part. And then for this part, where it says f of x, you would just do minus the function itself. So it would be x cubed minus 1. And remember to put this minus sign as you have to distribute the negative to the negative 1. So that could lead to a mistake if you don't do that. Then you put it all over h. Then that equals the limit as h approaches 0 of this. So then we have to factor this and stuff and cancel stuff out. So you would get x plus h times x squared plus 2xh plus h squared, right? And then you would do minus 1 minus x cubed plus 1 all over h. Now this would be equal to the limit as h approaches 0 of x squared plus 2x squared h plus x h squared plus x squared h plus 2xh squared plus h cubed. So the plus 1 and minus q cancel out, so it's just minus x cubed all over h. Then we get the limit as h approaches 0 of this, and here you can see that these two terms cancel out. Then you can see that this one and this one add. This one add. So you would just get 3x squared h plus 3hx squared plus h cubed all over h. Then that equals the limit as h approaches 0 of... So you see first that you have h has a common denominator. Ultimately, if you plug in 0 right now, it will get you to 0 over 0, which is indeterminate, okay? So we cannot do that, right? That's not possible in math. You can't divide by 0. So instead of that, you have to cancel out this somehow. And you can see that all of these share a common factor of h. So you essentially factor out an h. It would be 3x squared plus 3xh plus h squared all over h. Here you can see that there's a common factor of h, so you can cancel those out. So you get the limit as h approaches 0 of 3x squared plus 3xh plus h squared. Now, since we're finding the limit of h approaches 0, well, you know from your previous math classes, you always have to plug in for limits at first. Even though if it's not indeterminate, you have to first see if it's indeterminate or not. So here you would plug in, so it would be equal to 3x squared plus 3x times 0 plus 0 squared. And we know this is just equal to 3x squared plus 0, which just equals 3x squared. So f prime of x, the derivative, is equal to 3x squared. And this is true because there's a trick for the original problem. So we had to do x cubed minus 1 for finding the derivative of that. So the rule is you have to bring down the exponent and subtract the power of it by 1. So in this case, for example, x cubed minus 1, you would bring down the 3. So that would make it 3x. And you subtract this exponent by 1. So you get 3x squared. Another rule is that all constants like these are just 0 because of the same rule. So here the derivative would just be f of x equals 3x squared. So ultimately, the derivative of the function f of x equals x cubed minus 1. The derivative is 3x squared.